Hello, I'm Will. I'm operating the MEaSURE project, and right now I'd like to go through the process of submitting a measurement so that you can see everything that you need to do and what it looks like when you do so. Right now, I'm on the website that I'm running to distribute resources, give instructions, and also show results. But for today, I'm going to be submitting the data. If I click on this button, it'll lead me to a form, and here I can see just a little declaration of what information is being collected and why. I don't need to really go over that because I'm about to show you. But the first thing, of course, is on what date did you make your observations? Now, it just so happens that I'm recording this on Thursday the 19th because I'm not going to have any sun on the equinox, unfortunately. In fact, I didn't even have any sun today. I had to make mine yesterday. It's important to know what day the measurements were taken on because in a situation like mine, if you don't have perfect weather on the day, a day or two before or after, I mean, it's not perfect, but it'll do. And I want to make sure that that kind of timing difference can be accounted for in any assessment of error. Okay, so now that I've said when, I need to say where. This is going to find a location. And just in case you forgot what latitude and longitude are, there you go. All right, the latitude, I want that formatted in degrees and minutes. So this is where you actually are going to have to look up where you are. I'm going to pull up Google Earth, and I'm not really interested in telling the whole world and the internet exactly where I am. I am in Pennsylvania, and let me just find a location anywhere really can be good. Let's see, I'll just go in the middle of this river. You know what, actually, let me go up to Harrisburg. Let's just say I was, look, it's the Harrisburg Senators baseball field. All right, so I'll just go ahead and pretend that I did this right out in the middle of the infield. All right, so let's say I'm on the pitcher's mound, and I want to know where this is. So if I just make this a little bit bigger, I might be able to see this detail. It's kind of hard for you to see, but down here in the corner, there is a latitude and longitude. And if I just hover my cursor right there, that I can just clearly read, it says 40 degrees, 15 minutes, 23.23 seconds north, and then 76 degrees, 53 minutes, 23.87 seconds west. Well, there we go. That's my latitude and longitude. I'm just looking for degrees and minutes, and I'd like to explain why. As you may be able to tell, if I move, say, to the other end of this island, the minutes hasn't changed, right? I'm still within the same number of minutes of a degree. And that's because that amount of precision is sufficient to get a good measurement, but it's not sufficient to completely identify your location, which is, of course, a totally legitimate privacy concern. So degree and minute, it's enough to give us a good global idea of where you are, just not a good, look you up and find you kind of information. So the numbers I'm going to use are 40 degrees, 15 for north. Let me go back here, 40 degrees, 15 minutes, and then choose my hemisphere. I am in the northern hemisphere. And for longitude, see, that was 76.53. All right. 76 degrees, 53 minutes. Again, that's not where I took my measurement. I'm just using this as a sample location, and that, of course, is in the Western Hemisphere. If you are not in a hemisphere, if you're on the equator or along the international date line or the prime meridian, of course, there's an option for that as well. Okay, so I've said when I took the measurement. I've said where I took the measurement. Next, now what actually were the measurements? Okay, so since I chose that I was in the northern hemisphere, I've been led to a page that shows a reminder of what the measurement is and how to take it. And the first question that is asked is, at what time UTC did you observe solar noon? Now, as I recall, when I took this measurement, my watch said 1:13 p.m., but that was in the Eastern time zone of the United States. And also, we just started daylight savings time. So this could be a little tricky to figure out what time it is. I can just ask timeanddate.com. So this is, as I'm sitting here doing this, the current time in UTC, but my watch doesn't say 20, it says, well, 16, 4:30 p.m. So it looks like I'm actually 4 hours behind. So if my watch said 1:13, then UTC would have been 5:13. So let me go ahead back and enter my time. That'll be 5:13. I'm going to go ahead and choose PM. And then what was my solar azimuth angle? Okay, so if I go up here, it looks like I would need to calculate that as the arc tangent, the inverse tangent, length of shadow over height. That's this angle right here. Well, my shadow length was 79.5 centimeters, and the height was 100 centimeters. So, calculator handy, the inverse tangent of 79.5 divided by 100, a meter is 100 centimeters. That's 38.48, blah, blah, blah. I'll just round up and call that 38.5. That was my solar azimuth angle, 38.5 degrees. Okay, well, that's actually all of the technical information. I've said where and when I made the measurement. Then I said what the measurement was. That is the time and the solar azimuth angle. At this point, this is more just community building. I'd like to be able to track the reach of this project. And I know that if I was doing this with some students, I'm sure they'd be proud of their work and they'd like everyone to know that their school participated. So first, what kind of participants are we talking about here? If I had done this with my students, I might have chosen this for younger students, this for middle and high school students, college students. But since I did this one by myself, I guess I'll just put this one here. I'd like to be acknowledged as individuals or an institution. Again, if I wanted to put my school name out there and say, I'm just so proud that, so-and-so school participated, I'll just put my own name there because it was just me. And then optional, tell us about your experiment. The idea here is that if you're making a whole learning experience out of this, maybe coming up with ways to get a better shadow or find north without a compass or something like that, just any ways that you made this your own or put an interesting twist on it, that's what I'd like you to put here. And I think I'm just going to say I had to make this measurement quickly based on a last minute weather forecast. I had hoped I could wait to be closer, but I just couldn't. Okay, so that's actually it. At this point, I would hit submit. I'm not going to hit submit, of course, because I didn't actually do this measurement from the pitcher's mound of a baseball field in Harrisburg, but I can go back to the website and show you what it will look like afterwards. So if I scroll down here to the results and the analysis, so this is all of the possible calculations that could be made from every combination of all four of the current submissions. We're starting small, but looking to get new submissions every equinox. The calculated radius in kilometers is here with a percent error from the average value that's currently accepted. The average of our calculations is calculated here with a percent error and a standard deviation. And here is a histogram of the results. As we get more and more submissions, I'd love to see this turn into something of a normal distribution. So that's the results. I'd also like to share the data. That is because I didn't necessarily perform all these experiments. I performed a couple of them, but I would like everyone's work to be available for everyone to perform your own analysis if you would like. So here is a privacy protecting version of the results. Let me walk you through it. Oh, look at that. It recognizes that as a date. I'm going to have to fix that. Okay, so each row is a separate submission. You see a timestamp of when the data was submitted, and the date of the measurement itself, what hemisphere they were in, and then a calculation of the latitude and longitude. Yeah, it looks like I have to edit that to make sure that it doesn't recognize it as a time. Spreadsheets, am I right? Okay, so this is the time that they reported solar noon occurring. And as you can see, some of these have a false next to them. That is because one of the things that I need to do is verify, did they actually change it to UTC or did they just keep their current time? So I do have a kind of common sense calculation that will flag it if it's more than a certain number of hours away from what is expected. I have to allow, an hour or two for daylight savings time or being in the wrong time zone. So if it's flagged with a false here, I'm going to have to manually look up what the UTC correction would have been and put that in. And then here is the UTC. Here's one that I had to change manually, but that's just what it takes. So minutes here, that is the number of minutes after the beginning of the day that their solar noon occurred. And our longitude check here, that is how I check that this makes sense. That is based on this longitude, right? The reported longitude. Does it make sense that it would have been this many minutes after the beginning of the day that they would have had their solar noon? It's just a simple ratio. And so if the number is 1, it was perfect. Just looking for if anything is substantially off of 1. These are all within 1%, so that's fine. There's the reported solar azimuth angle. Okay, so everything here is the data that you need to do your own calculations. I've got one more common sense check here. Solar azimuth angle should correspond to the observer's latitude. I'm just making sure it's within 2 degrees so that there isn't a substantial error. Now, obviously, if there is a measurement that's submitted that is problematic, there's some sort of obvious error with it, for example, the wrong reported time, that's something I could catch, just adjust the time zone to so that it makes sense. But if there's a submission with some sort of anomaly where I can't make sense of how that number came out, sometimes you get bad measurements. I just want to be able to flag that. And lastly, we have a map here of all of the submissions that have been made so far. There would be 2 here. Those are the ones that I made. Here's submission number 1. There's submission number 3. And yeah, so you can use this data once I correct that format to do your own analysis and calculations. This is publicly sourced data, so it's publicly available as well. And just a quick, snappy summary of the results is right here. So I would love to see a representation from every single hemisphere, north and south, west and east. And once we have a sufficiently large amount of data, then the standard deviation might actually mean something. And like I said, we're going to get a nice, something like a normal curve here. So since I've kind of finished that, I just want to throw a few words here at the end. I love teaching math and science. I love the history of discovery. Really proud to be a human sometimes. And rather than just learning that people have done these amazingly intelligent things in the past, it's really important to recreate them, and that feels like kind of a cheat when we use modern tools to do things that weren't available at the time. I don't have the means to, pay for someone to walk across the ocean to measure a distance personally. So I am using these submitted latitude and longitudes to calculate a distance. But other than that, everything that we're doing was available a long time ago. Just a stick with a shadow, something magnetic to find north or south, and an ability to tell time. That's really it. Okay, well, I'm really happy that you're watching this, that you're considering participating in this experiment. Please check out these resources if you're doing this with students. You might find these slides as a useful thing to introduce the students to it. I've got some data sheets for when you're actually performing the experiment. But anyway, this video doesn't need to be any longer. Thank you very much for considering and participating, and I'd love to see your results.